All right, we're going to start out with what seems like a really easy question, and of course it's not. A very elastic rubber ball is dropped from a certain height, hits the floor with a downward speed v. Since it's so elastic, it bounces back in the same speed v going upward. Which of the following statements about the bounce are correct? There could be more than one correct choice. So we got to be very careful in how we read this. The magnitude of the ball's momentum, so p the ball, is mv. The magnitude means it doesn't matter what the sign is, so we don't care if v is positive or negative. So this one is correct because it tells you, because it's so elastic, it has the same v. It's upward, but again, magnitude means we don't care about the direction. So A is good. B, the ball had the same momentum just before and just after the bounce? No. It had the same magnitude, mv, but because of the negative bounce, it's not the same magnitude. We have to say no to that. The ball's momentum was conserved during the bounce. That is also incorrect. Normally we say p before equals p after is always true, but this is for the entire system, sort of the ball and the ground. Think about it. mv is turning into m negative v. That's not conserved. Right? They're opposite. None of the above are correct, so that can't be. So A is our answer for this one. All right, three objects are moving along a straight line as shown in the figure, taking the positive direction to be to the right. What is the total momentum of the system? I don't know if I can see these. So you have 5 times 8, where it's positive, plus 4, negative 4 times 15, plus 2 times 3. So 40 minus 60, negative 20 plus 6, negative 20 plus 6, negative 14. Double check my math, but I think the answer is negative 14. I have it all out of order here. Can't really see too well on my screen. MV, MV, but the V here is negative, and MV. All right, so Jennifer is stranded in space, floating 100 meters from her mothership. To get back, she suddenly throws her 2-kilogram wrench at 20 meters per second in a direction away from the ship. So Jennifer's here. The ship, whatever a ship looks like, I don't know, is over here. She throws a wrench in this direction. So MV of the wrench in that direction is going to equal MV of Jennifer in that direction. This is an explosion. Whether you believe that or not, it is. So how long does it take her to coast back to her spaceship? So we're going to figure out what V is and then do V equals D over T. So P before equals P after. 2 kilograms times 20 meters per second equals, her mass is 200 kilograms times V. So the V after for her is going to be 0.2 meters per second. That's going to equal D over T. So D divided by 0.2 equals T. And the D here is 100. So it's going to take her, how many seconds? 500 seconds, which is B. Calculate the impulse due to a force, so F times T. It's nothing like these questions getting easier. They're usually supposed to get harder. You do the math. I think you get 6.3. There's that one. And the last question on this page, it's an elastic collision, so you're going to have to combine P before and P after with VA. VA prime equals VB plus VB prime. So MA VA plus MB VB equals MA VA prime plus MB VB prime. You plug in. I'm going to wait to do this because class is starting. Alright, so to try and finish this problem, there's about 50 kids in my classroom during my lunch hour. We have the two equations, because it's an elastic collision, basically just have to plug and chug at this point and solve the two. The second one was stationary before the collision, so those are 0. They're given in grams. I would convert them to kilograms. It might not matter because everything's in grams, but better safe than sorry. 0.32 times 1.25 equals, I'm using this equation here, 0.32 mv, oops, not the m, excuse me, VA prime plus 0.27 VB prime is one equation. My other equation is 0.32, I keep doing that, 1.25 plus VA prime equals VB prime. So 2 equations and 2 unknowns. I guess I'll just substitute this in here. You know what, I'll let you guys finish the math. It's not worth your time to watch me go through it. The answer ends up being 1.36 meters per second for the 270 gram one. That's VB prime. All right, one more page.